All right, so we're getting into 4.1 today, exponential functions. Don't forget if you're gonna take that makeup, it is your makeup has been posted in my math lab already. You should be able to see that for chapter 3's test. All right, so exponential functions, exponential function f with base b is written in this form right here. You have f of x is equal to b to the x power. So your variable is in the exponent, so that's what makes it exponential. Or y equal to b to the x. And say b is a positive constant other than 1, and x is any real number. So once again, your variable is your exponent. So this is not bx or b times x. This is b to the x power. Mm-hmm. All right, so first exercise, they ask us to graph your exponential function. Of course, if I scroll up too fast and still copy it, let me know. So if they gave us these variables, not these variables, these numbers to plug in for our variable x, then we would do so in this fashion. Take each one of them, take 3, 2 to the third power will give you 8, 2 to the second power is 4, 2 to the first power is 2. Anything to the 0 power is 1. All right. And then anything, when you talk about something being to the negative power, to make it positive, you drop it down into your denominator. So that'd be 1 over 2, then 1 over 2 squared, which would be 1 over 4. Then 1 over 2 cubed is 1 over 2 cubed, or which is 1 over 8. And that's how we would fill out the chart. So that's how we got those values for the chart. So I'll give you a chance to copy that down if you want to do so, and then we'll look at the graph. All right, so when you graph those values, your exponential function looks like this. And so notice that it goes up quickly, and the more your exponents, the higher exponents get, the higher your number starts to grow and jump. And so that's where that term comes from, growing exponentially, because it grows real fast, skyrockets. All right, any questions on that? All right, your natural base, E, that's not a variable, that is an actual function, or that actually has an application. E to the first power is a value, so that's 2.7182818, on to infinity. So whenever you see E in mathematics, scientifically, that carries value. All right. That's your natural base, and that's going to come back up later. So compound interest formula, some of you may have seen that before. For n compounding periods per year, A is equal to P times 1 plus R over N raised to the N times T power. And we'll talk about what the letters mean in a second. Just give you a chance to copy it down. Then for continuous compounding, A equal to P times e to the RT, and that E is your natural base. So you're not going to plug in a value for E, that's your natural base. So we're talking about, when it comes to banking, owning money, owing money, or taking out a loan, something of that nature. Compounding periods, how many times your account is going to get hit with interest, so that's what we're doing here, trying to calculate that and how much money would be left in your account after a certain amount of years or a certain amount of time. And so P is your principal, which is your deposit or loan. R is your rate. Don't forget to convert it to decimals before you do your calculation. T is your time in years, so you will convert that to years if necessary. N is the number of compounded periods per year, and then A is your future value, how much will actually be in your account after a certain amount of time has passed. All right. So when it comes to number of compounded periods per year, there will be keywords that will let you know what N is going to equal to. So annually, N is going to be equal to 1. Semi-annually, N is equal to 2. Monthly, N is equal to 12. Quarterly, N is going to be 4. Weekly, 52. And then daily is going to be 360, not 365. It's going to be 360 because of Banker's rule. All right, so let's put these formulas to work. Says you just.
Can you go back? I was copying that.
Oh, all right. Let me know when you finish.
Thank you.
Yep, no problem. No problem. All right. So says you decide to invest $8,000 for 6 years and have a choice between two accounts. The first pays 7% per year compounded monthly. The second pays 6.85% per year compounded continuously. Which is the better investment? So when you go back to your formulas, just want to make sure we emphasize that, if you have a compounding period, then you use this formula. But if it's compounded continuously, then we use this formula. So we're going to be using two different formulas here. So as always, I like to write down what my given information is. So that's what I did here for my first account. $8,000 is the amount we're going to deposit. This is my principal. 7% is 0.07 for 6 years, compounded monthly. And so right here, plug that into the calculator like this. If you need help with your calculator and how to use your calculator, what functions you have on your calculator, then feel free to get with me on that. I'll do whatever I can to help you out. But if you have a calculator that allows you to type in your stuff like this and just put it on the screen, then that will be the way to do it. Make sure you use parentheses and everything appropriately. And you should get $12,160.84.
I was not able to write the whole problem from the top. Thank you. Okay, can you scroll up?
Mm-hmm.
Thank you.
Mm-hmm. All right, so looking at our second account, you have $8,000. Once again, we have $8,000, that same $8,000 that we deposited into the first account. We're just trying to see which account is going to be the better investment. I already have a hint right here which one will work out best for us, but that's all good. So our rate is 6.85%, which would be 0.0685 time 6 years still. This time we're compounding continuously. So the first account we had our the difference was the rate was 7% and we were compounding monthly. This time our rate is 6.85% and we're compounding continuously. And so we used a different formula. So we see it down there at the bottom in red. Put it in the calculator and we get $12,066.60. So comparing the two prices, we see that the first account is the better investment because we get more money when everything's said and done. So at the end of the 6 years, we get a little more money. right, questions? Any questions on that? All right, good to go. All right, so that's all they ask of you in that section. Any questions on that before we go to the next one? So we'll do 4-2 and call it a day. So now we're looking at logarithmic functions. Initially, we were looking at exponential. Now we're looking at log. So x is positive. That's what x is greater than 0 represents for us. And b is positive. And then it says, of course, b is not equal to 1. Then your logarithmic relationship, y equal to log base b of x. So that's how you would say that, log base b of x. And that's going to be equivalent to b to the y power equal to x. So both of these represent the same relationship of what they're saying, just written in different forms. Notice that when you're going between or switching between the two, that your base is always going to be the same. So it's either the base of your log or the base of the exponent. And the only difference is that, and the way I look at it is that whatever is next to b in one relationship should not be next to b in the other relationship. So you see we have y over here, y is right here next to b, x is right here, and x is right here, not next to b. So that's kind of way how I translate it, and you'll see what I mean when we put some numbers on it. But your base, you always start off with your base. Your base is going to be the same no matter which relationship you're using. So in the red, the function f of x, log base b of x is the logarithmic function with base b. And this is just re-emphasizing the relationship. That's log form, y equal to log base b of x. And then b to the y power is equal to x. That's your exponential form. All right. All right. So they give us expressions in log form. They ask us to write in exponential form. So that's what we'll look to do in A, B, and C. It says 2 is equal to log base 5 of x. All right. So like I said, the best way to translate from log to exponential form is to start off with the base. The base is going to be the same no matter which relationship you're writing. So we have 5 is the base of my log. So 5 is going to be the base of my exponent. So the x is next to the 5 in my log form. So that means it will not be next to the 5 in my exponential form. So it'll be 5 to the second power equal to x. All right, same thing here. Log base 3 of 7 is equal to y. 3 is my base, and my y will be my exponent. 7 will be what it's equal to, so that's 3 to the y power equal to 7. Then in the next one, a is my base, and since it's next to 64 over here, it will not be next to 64 in my other relationship, so that'll be a to the third power equal to 64. All right, any questions on that? All right, so do the same thing, but let me write that. We're going the other way with it. So we have the exponential form we're going to write in log form for the next 3. So just like before, we want to start off with the base. So we have 12 squared is equal to x. So 12 is my base, so it's going to be the base of my log as well. And so 2 is next to the 12 in exponential form. That means x will be next to the 12 in my log form, and then the 2 will be on the other side. B cubed equal to 8, so that's log base b of 8 equal to 3. And then we have e to the y equal to 9, that's log base e of 9 equal to y. All right, any questions? Any questions? All right, can scroll up. Pretty good. All right, so we have 4 general properties of our logs. So that base b is going to represent any base that you have. So log base b of 1 is always going to be equal to 0. So any base, log base of any base of 1 will give you 0. So whenever you take the log of 1, it will give you 0. Notice here, 2 and 3 properties, 2 and 3 are related. Log base b of b will reduce down to 1, but that's because the exponent is 1. If you notice here, for the third one, log base b of b to the x, notice they cancel out and just leave you with the exponent. So that's basically what 2 and 3 are emphasizing, that if you take the log base b log base b of b to whatever that exponent is. If you have that scenario, your exponents will be what's left. Then if you have b raised to the log base b of x, that will cancel it out and leave you with just x as well. So notice that this is your exponent right here, log base b of x, and so they will cancel out. So over here in the purple, we see me just do a few, many examples of what they're emphasizing. Log base 5 of 1 is equal to 0. Log base 7 of 7 is equal to 1. Log base 4 of 4 to the 5th power cancels out and leave you with just a 5. And then 8 to the log base 8 of 9 will cancel this part out and leave you with just 9. All right, any questions? Any questions? All right, so now common log is going to be log base 10. So in your calculator, there will be two logs that will always be there. And one of them is the common log. If you don't see anything, they assume that you know there's a 10 there. So you can never write log nothing and assume that there's anything there other than 10. So that's why it's called the common log. When you have nothing there, they assume there's a 10 there for the base. So those four properties apply to the common log. Log of 1 is 0, because log, no matter what the base is of 1, will always give you 0. Log of 10 will give you 1, because remember that is a base 10. Log of 10 to the x will cancel out and give you x, and then 10 log of x will cancel out and give you x as well. All right, next one is the natural log. That's log base e. So when you see ln of x, that's your other log. There are two logs that are automatically programmed in your calculator if you have a scientific calculator. That's the common log, and then your natural log, ln of x. If you see ln, then they assume that's log base e. And those are the properties, those same four properties apply to the natural log. All right, any questions? All right. So we have a few that we want to simplify using the fact that we have common logs and natural logs. Let me erase some stuff so we can walk through it. All right, so we have log 100. And since we have this log and it's the common log, when you don't see anything there, they assume you know there's a 10 there. We will look to rewrite that 100 as 10 squared. Only reason is because we know that our base is 10, and that's what will help us out. So log base 10 of 10 to the second power. Not exponent rules, our general log rule says that that will cancel for us and leave us with just 2. All right. Next one, log rule 10 to the log of 33. That just cancels and leaves you with 33. All right. Next one, we have to rewrite this one. And so we'll rewrite it as natural log of e to the negative 6. So we want to bring this exponent up into your numerator. We can do that by rewriting it as a negative exponent. Then from there, using our log rules or log properties, natural log and that e will cancel. And that leaves you with just the exponent of negative 6. All right. Next one cancels as well. E to the natural log of 75 leaves you with just 75. I'll just leave that. All right, so in this next one, right here, we have log base 3 of log base 7 of 7. So what we do is what's on the inside of our parentheses first. Log base 7 of 7 is 1. So it's log base 3 of 1. And anything or any log applied to 1 is just 0. All right. And the next one, we start off with this right here, log base 5 of log base 2 of 32. And instead of rewriting it, we can just go ahead and leave it the way it is. As far as me rewriting it, we can just walk through what I wrote. We have log base 2 of 32. Since I have this 2 right here as my base, it would be good if I can rewrite that 32 as an exponent of 2 or a multiple of 2, and that's what I did. I recognize that 32 is 2 to the 5th power. All right. So now I can simplify log base 2 of 2 to the 5th power. That gives us just 5. Then log base 5 of 5 would be 1. right, questions on that? All right. So, yep, that's it for 4.1 and 4.2. Try those out. See if you have any issues with them. Make sure you bring those questions to class if you have them, or shoot me that email. And we'll pause right here. We don't have to go into a new section necessarily today. We have 2 of them in our belt, under our belt. All right. So, any questions or concerns before we close out? Got it good, everybody straight. All right. Well, you guys have a good one. Have a great weekend. Be safe. And I will see you on Monday.
Bye. Have a good weekend.
Thanks. You do the same. Take care.